Thank you very much, Marietta. And you are right. It's the fourth time that we are doing this presentation. And it's the fourth time that I am changing the presentation also. So you may understand immediately that I'm French, and I've been spending 28 years, in the oil and gas business, and the last 2 years with Nel. I will be talking about a new facility, a unique facility that we are finishing to build right now in East Kilbride in Scotland. And very often I will use the abbreviation AMF, but it means Advanced Multiphase Facilities. So before I go further in my presentation, you may see a lot of logos, on this first slide, and I should try to explain a few of them. You may see on the top right in a corner, TÜV SÜD, and you can see Nel, and this obviously is a company where I am working right now. The facility that I'm presenting after, can exist only because there is two main companies that have been investing a fair amount of money, as you will see it later. The mother company of Nel, TÜV SÜD, and obviously the Scottish enterprise. And finally, you may have seen the BEIS on the top, and they are supporting us, in this webinar, Okay, let me just do that. It's a technical part on my side, So just before continuing, let's go through the normal process. Some of the statements I will be doing today, I will be making today, are forward-looking. They are subject to dependency of things outside of my control. And obviously, if someone should be blamed here, it will be me and not Nel. So. This will be our journey through this presentation, and I wish to explain you first what is a market, what was the need of the market and why we have been building new facilities, and this is based on the dream that some of you had. Obviously, when we have been thinking about developing these advanced multiphase facilities, we have not been looking, for the next few years, but we project ourselves over the next 20 years plus, We will tell you after how we have been able to answer the need that you had, I'm talking here either about the oil and gas company or manufacturer of multiphase flow meters, and you had different requirements, obviously. Obviously, this is addressing, different departments, in oil and gas. You will see it's probably about production, allocation, but also, and quite important, about the authorities. If you make few percent or even 0.1% error on a massive amount of oil, there is a lot of money which is not accounted by one or the other partner, and obviously tax associated with that. I will also go a bit beyond the MF facility and tell you what we have been developing and proposing also in these advanced multiphase facilities, and you will understand much more why we call it advanced multiphase facilities, and then we'll have the conclusion. So I guess most of you know about NEL. We are a national measurement institute, and we're the only one in UK in charge of flow measurement and density. We are in this business since 71 years now. And we have multiple facilities, and this was presented in the different webinar, during last year, So what happened? It's over the years there is some need, and we look at some need which are changing, and we are looking how to address this need. And over the last years, and I highlighted, 2012 and 2014, we have been upgrading the facilities that we have, but we discovered that by 2014. It was necessary to change the way of thinking and have a game changer, as I said here, to be able to address three main markets from my point of view. One, which is the subsea business, which has been growing, and after the crash from 2014 to now, it's picking up. I can see it. We wanted also to address the large producer, there is wells today, which are either 8-inch or 9-inch or 10-inch, and we wanted also to address the production market. You can think about an FPSO if you want, or refinery side, where you may have multi-phase flow and you want to be sure that you have accurate measurement. So what we decided by 2014 and just after that was to make a survey, and we have been discussing with a lot of customers that I will be explaining just after, and looking, what should be necessary for the oil and gas business from a multi-phase point of view and wet gas point of view for the next 20 years. Okay. So the main ideas for us were the three bullets that I'm presenting just after. Understand the market change, which obviously will happen over the years, and we are obviously projecting ourselves over 20 years, and we may make some errors, but we need to minimize these errors, and therefore, discussing with most of the oil and gas company was very important for that. We wanted also to see if the market was growing or not, if there were some game changer, or if people wanted to use more standard way of thinking, and also wanted to make a differentiation of what we got, what we collect, which sometimes are nice to have, and what is really the future for you and us. Okay, so we have been doing over a few years, and we have been contacting, as I said, is our key customers, and we have the oil and gas operators, can be national oil companies or international oil companies or some independent also. We have been also talking with some manufacturers of multi-phase flow meters, EPCs, which are buying this equipment, and provide a solution to the oil and gas operator, and also the legal authorities, which are associated with tax, and obviously the UK government in one way. So what came out of this survey, it's the 7 main bullets that I'm presenting just below, And the first one is about the subsea market, which is growing. It's not obvious at one moment if it will be continuing to grow with the turmoil that we have been going through, but as I said, this has been changing over the last 18 months, and definitely this market is growing. And there were a special need on this market where, you need to be sure that multi-phase flow meter or wet gas meter are working very well, and they had the wish to see independent tests and impartial acceptance tests. Very often today you do a factory acceptance test, but is not in a third party or accredited facilities. So this was the first main bullet. The second one was facilities capable to handle much higher pressure. Very often today the facilities existing around the world are, let's say, below 60 bars in general, and the subsea market required, or even the gas well require higher pressure, The third one was what we have seen over the years, and you may know that, it's what I call a cleaner hydrocarbons. Essentially, we're talking here about gas condensate, wet gas, or very light hydrocarbons, We want to try to be as green as possible with such hydrocarbons. The fourth one was a facility capable to address the wet gas business, but also capable to demonstrate that any system tested on these facilities could handle a large amount of liquid loading, and this is what I mentioned here, going from wet gas to multi-phase flow. And if you want to look at it from a well point of view, I'm saying it's from condensate to volatile oil. The fifth one was a facility capable to address the large flow rates. I mentioned it slightly earlier. You have all these floating facilities today. The FPSO. You have lately the FLNG coming. The production manifold and subsea wells, as I mentioned. Which are 8 to 9 inch tubing. The sixth one. It's obviously, they wanted something extremely accurate in terms of facilities to be able to challenge the performance of the meter, and the specification given by your manufacturers. And obviously, they wanted to have these references auditable in one way or another for the 3 phases, And the fifth one was a facility capable to handle some specific variation that will happen during the life of a well, which is a salinity change, pressure change, or the gas content, and the GVF here means gas volume fraction, how much gas is flowing through your pipe. And obviously, with the life of your well, the pressure change, you may have less or more quantity of gas going through your pipe, and therefore the performance of the multiphase or wet gas meter may be changing drastically. So I'm not in 50 minutes, and I'm sure I will be a bit long, but they will try to cut me as quick as possible when I will arrive at my time. I will take only one of these key points, and I wanted to take the most challenging one, which is about accurate measurement and auditable reference measurement for validation of multiphase flow meters. And I will go through this one. Probably I have 7 slides talking about these topics, but I think as soon as you will understand this point, you will understand the next part of my presentation. So when we talk about accuracy here, obviously people want to get the best reference measurement that is possible, and also ensure that the uncertainty associated with this equipment, is auditable and traceable. This is absolutely compulsory. And the other one is the need to calculate the measurement which is coming from this reference meters, to the meter condition. You may understand, for some of you, when you are flowing, there will be a pressure difference, inside your pipe, and therefore, if there is some gas which is dissolved in your oil, a bit further in your pipeline, you will have this gas coming out, and you need to do some conversion here. And this were really a key point that we have been discussing a lot internally to nail, And we should keep in mind, as I said earlier, that we wanted not to address only the business for the next coming years, but really building something which is quite strong, and on the fact that we are a national measurement institute, for flow measurement and density for the next 20 years. So we wanted also to look at something that we feel is not really well addressed today on the market, but it was to be able to establish and validate the performance of the multiphase flow meter or wet gas meter, not only for the manufacturer, but also for the end user. And later you will understand why I mentioned these two. They don't have exactly the same expectation, and therefore we should address both of them, the one using the meter at the end and the one building or manufacturing this equipment. We wanted also to be able to address the different type of oil which is existing on the market, which is from heavy oil and to gas condensate. And we wanted, as it was highlighted earlier, to address the wet gas business, which is growing very fast, but we should not forget that we are producing still around 100 million of barrels per day of oil, and therefore we need also to address this one and be able to move from one side to the other side without a problem or seamless manner, as I mentioned it here. So what are we dealing? This is a question that I'm mentioning on the top. What are we dealing with the testing of a multiphase flow meter or wet gas meter? You may see in my slide later, MPFM or WGM, so multiphase flow meter or wet gas meter. So the idea is we want to provide the best and the fairest flow meter evaluation, and that this is a key for us, knowing that there is some modeling and technology dependent, following what you are using. Do you use nuclear measurement? Do you use optical measurement? Do you use resistivity, electromagnetic measurement? The response of your meter may be different in the same flow condition, and therefore we need to be able to evaluate it in a proper way. But we need also, and it's not the least, the fluid behavior dependency, as I will explain just after. So first, to do a comparison, we will need to have some very good reference measurement, and thereafter we will do some flow simulation, and therefore we will have some data from this multiphase flow meter, and we will look at the, if I can say that, the discrepancy between the two measurements, And somewhere when I'm talking about discrepancy, we need to understand we are evaluating the uncertainty of the multiphase flow meter against the reference. So there is obviously some requirement that you need to have on the reference measurement, and I list them here. The uncertainty will be a combination of the primary instrumentation, for example, pressure, temperature. They have some uncertainty associated with them. If you use a single-phase meter, there is some uncertainty associated with them. So obviously, you will need to select the best equipment, but there will be still some uncertainty associated with that, and you will need to take into account this one. You will need also to take into account the conversion from this measurement from your reference meter to either standard condition or to meter condition, where you are looking the performance of this multiphase flow meter. And I mentioned it just after, the goal here is if you want to state a specification about a meter, you need yourself on the reference side to be 3 to 4 times better than the expected specification, unless it's a bit more complex to evaluate properly the performance of this meter. So keep this in mind. A reference measurement uncertainty should be extremely good and 3 to 4 times better than what a manufacturer will be claiming. Okay. So now let's look at a bit the uncertainty associated with a multiphase flow meter or wet gas meter. It's the same thing. Here it's still a combination of primary instrumentation uncertainty. They will have some pressure, they will have some temperature, they will have some other techniques of measurement or technology in this domain, to calculate, the fraction of oil, water, or gas, for example. But there will be also some assumption, associated with the multiphase flow. And obviously there is, due to this assumption, or due to the calculation, there will be some uncertainty associated with that. And like above for the reference measurement, there will be also some PVT conversion from line to standard condition. And with the big pictures, we will have these 3 combinations here. And again, we are expecting that the green one should be 3 to 4 times better than the red one. So a lot of words here, but sometimes I like to make a cartoon, and I'm showing you that right now. You can see on the left side, the big arrow, it's the overall flow meter uncertainty. Keep in mind the overall will be, for me, mentioning 3 types of uncertainty. The one which is associated with the instrumentation, which is in the bottom. The one which is associated with the modeling, the physics, the data processing, the techniques of averaging that you will be using, and the fact also that this multiphase flow meter and wet gas meter are a concentration of a different type of technology, and therefore there will be some uncertainty associated with that. And the third one, which is on the top, which is either you talk about fluid behaviors, or some people will talk about PVT, so I use the 2 names there. So if we try to highlight what I said earlier, the primary instrumentation will be the advanced electronics, the PE, the pressure, the temperature, the differential pressure, and after, as I mentioned it, the combination of technology, the data computation, the modeling of the fluid mechanics, which obviously is something quite challenging to do, And on the PVT side, you will have 2 types of PVT, if I can say that. There will be the input parameters, how do you set your meter in a proper way that it will be calculating something which is making sense. Some of you may understand it's or you may say very often, garbage in, garbage out. So you want to avoid this garbage in. So therefore, you will need to look at what is the effect of these input parameters on the overall performance of the meter. And obviously, as I said, the output performance, which usually is from line to standard condition. So how can we address them? And the first, the 2 big uncertainty, will be addressed by using a third-party flow loop. Obviously, if you are developing a multiphase flow meter on one facility and you are testing this meter on this facility, you should see the meter working, because by definition you were collecting data and then you were looking at how it was matching the reference, and then you were modifying, changing some assumption, and therefore you need definitely to go to a third party and not facilities that was used, to develop your technology. You will need obviously to use an facilities, which has proper and auditable uncertainty, unless people may tell you, they are within 1%, but is it really 1%, or is it 0.2%, or is it 5%, So therefore, here you need to be careful, when you want to state the performance of a meter, either as a manufacturer or as an end user or an EPC, you will need to select the relevant facilities, and there are not so many around the world, and we all know each other. The second part, which is, as I said, garbage in, garbage out, this can be addressed in a different manner. Either you can use the data from these meters, and you can change the input parameters, and you can see through some playback, some way that some of our customers are giving us software, how impact the output parameters. Or you can, on purpose, if you don't have access to that, on purpose change the setting of the meter, and in this case, look at what will be the outcome in terms of performance. And the third one, which is the most important one for me, it's how do we do the conversion from line to standard condition. Very often this equipment, this multiphase flow meter or wet gas meter, are used in a high pressure, and therefore the conversion from line to standard is very important. And you need to be able to use some PPT package which are traceable and auditable in one way or another, and capable to provide an uncertainty on the different measurements that we need. Some of you may know that, we are looking, for example, the shrinkage factor of the oil, the expansion factor of the gas, how much oil is dissolved, how much condensate is dissolved in the gas, or how much gas is dissolved in oil or inside the water. So there is some key parameters here. There is roughly 10 parameters that needs to come out from a PPT or an equation of state. And what is very important is not only to get the number, but is to get the uncertainty associated with this number. And this is very difficult to find. I mentioned one of them here, PPDS. We are key on that. Here in NEL, we've been spending the last 40 years to develop this equipment, of this PVT package, for the downstream business and now for the upstream business. So I mentioned a lot about the conversion from line to standard condition, and again, a lot of talk, but let's take a quick example for everybody. The oil and gas industry are dealing with live fluid, and you will say, Bruno, what is a live fluid? Well, if you think a bit about the beer, or the champagne, or the Sprite, like I mentioned the Coca-Cola, for example, when you open the bottle, there is some gas coming out, so this is telling you that the liquid under a pressure, the pressure that you have inside the bottle, is dissolved. In this case, it's essentially CO2, but when you open it, it starts to come out, and therefore you have some gas. So imagine in a well, you have exactly the same thing happening, but usually it's not some CO2, but it's some alkane, like methane, ethane, and so on. And obviously there is some value associated with that, and you want to quantify very well this amount of gas, which is associated with some money, obviously. So let's imagine we look at one of the equations. There is plenty of equations, and I'm taking only one of them, and what I'm saying here in this formula that you see, it's the oil flow rate at standard condition, SC standard condition, is equal to the shrinkage, the BO, times the oil at line condition, plus another parameters, R times BG, and BG is the expansion of the gas, and QG is the gas at line condition. So this will be in a simple manner the way to calculate the oil at standard condition, and you can see that there is three parameters here, the BO, the BG, and the RG, that you need to know, because the multiphase flow meter will not give you this information. So let's make a simple propagation of error, and we will assume that there is no gas dissolved in this oil. Believe me, this is an equation that you will get, just below, if you want to calculate the uncertainty of the oil at standard condition. This is a relative uncertainty. And now let's look at a bit the story. So if a manufacturer is telling us that the uncertainty on his meter, is 1% on the oil flow rate, we will have a tendency to think that, well, it will be also 1% at standard condition. But imagine that you have the shrinkage factor, which is not better than 4%. In this case, you will never reach 1%. You will be at 4.1% in this case. So this is to tell you how important, is the uncertainty on the fluid properties. And believe me, sometimes multiphase flow meter can be good at line condition, but people are forgetting that the conversion from line to standard condition, it's a key part. Okay, so here we were 4 times bigger than the expectation if the end user wanted 1%. So to summarize a bit about the fluid properties and the uncertainty, and it sometimes could be a bad news for some people, oil and gas, we are dealing with live fluid all the time. It's only really when we are going to the bunkering system that we are not anymore with 2 or 3 phases or 4 phases, but essentially with 1. There is always gas dissolved in oil and water, in one way or another, or there is some gas which can condense at standard condition. It means in a way or another, see it with the water. You can have some steam and under pressure and temperature, and at standard condition, obviously, this steam will become fresh water. And it's even more complex in this case because you are taking into account some fresh water and some salty water, and you will need to do some correction here also. Okay. So if someone is telling you one day that the PVT is something that you should not look at carefully, definitely it's either someone who didn't understand very well what's happening, or they are absolutely disregarding, the fact that there is what we call, in chemical industry, some phase transfer of molecules from one state to another one. Okay. Again, I'm not going further than that, but think either about champagne, Sprite, or if you are better, with some mechanical equation, and then you will see a bit where we are. So this speech that was a bit long here is to tell you that at the end, after some challenging question and meetings here, we decided that we will use some non-miscible fluid in order to achieve the highest uncertainty that is possible, in our facility from a reference point of view, and therefore be able to look at the true performance of the multiphase flow meter or wet gas meter under test. Okay. So, and the main reason are here, the PVT package in this case will be extremely simple, and we are really expecting, we have seen it over the last 20 years, significant improvement in the performance of the multiphase and wet gas meter, and therefore we need to be ready to deal with equipment over the next 20 years that we will have a specification quite low, let's say probably within 1%, and therefore we need to be sure that the reference is still 3 to 4 times better than that. Okay. In summary, if you have understood a bit my French-English talk, there is 3 distinctive parts in a way we are qualifying a multiphase flow meter. There is obviously the performance on the flow rate, at meter condition. This is definitely what the manufacturer wants. But we look at it also from the end user point of view by looking deviation in the settings of the meter and by looking carefully for each meter what is the process going from line condition to standard condition. And therefore, with these techniques, we are capable to address any type of fluid and in a seamless manner, So I think I've been spending a lot of time, trying to explain you some of the strategies that we have been taking, over the years to define these advanced multiphase facilities. And now let's start to see some pictures, about what came out, over the last 18 months. So I'm currently in this yellow box somewhere there, in Scotland. And you may see the red box, which is the current facility that we have. We have a multiphase facility and a wet gas facility, single-phase facilities, erosion facilities, and so on there. We have 9 facilities, in fact. And the white box that you can see just in front of us, this is AMF, well, it's called the Reynolds Building, and it's where we have the advanced multiphase facilities inside. Okay, let me go here. Okay, I had a teeny problem with with my fingers. So this is the layout. I will show you some pictures. I will start from the right side. This building, it's 80 meters by 20 meters. I mention it a bit later, but for some of you, if you are in a football, we are talking about almost half of the size of football field, So in purple side, on the right side, you can see gas blower and pump. We will be using 2 pumps for the oil, 2 pumps for the water, and 2 gas blower, and you will see the type of flow rate that we are planning to have. The yellow box, it's where a client, a customer will be present. The red box is a control room. And in orange, you can see the separators. We have a very, very huge separator. I will show you a pictures. It's 33 meters long and almost 3 meters in diameter. And we have a pre-separation stage upstream, which is 10 meters long and slightly more than half a meter in internal diameter, Obviously, as I said, we need some reference. So the blue square that you can see, this is where we'll have all the references, for the oil, for the water, and for the gas. And the manifold, this is where we will be mixing the 3 phases. And in green, you can see the area where we can install multiphase flow meter or subsea modules or whatever we want. There is some cranes, to move all these things. To give you a picture, we draw 2 trailers, that can go physically inside and bringing any equipment if they are very heavy, and we cannot use any forklift for that, So I show you a picture on the left side. This is a building last year, when it was empty. As I say, 80 meters by slightly more than 20 meters. And then in the bottom one, you can see in blue the separators, which is up, and you can see the size of this yellow stand, and because you can see on the top right, some people nearby, they are at 8 meters. They are 8 meters tall, and as I said, this separators, it's 33 meters long, 270 tons here. So seen from the other side of the building, or the corner of the building, you can see where we are, a few weeks back. We are now finishing. The pump has been installed. If you look at it on the left side of the pictures on the right side, the pump are in place, the blower are in place, and now we're starting to lay all the pipe for these facilities. And the pictures on the left side show you, with different colors, green, gold and red and blue, all the piping that they are starting to put in place now. And I want to spend a minute here to say that this facility could not be existing today if the 2 main companies, TÜV SÜD and Scottish Enterprise, didn't participate to that. We had almost $16 million coming from TÜV SÜD, the mother company of Nel, and we have almost $6 million coming from the Scottish Enterprise. So you can see our relationship that we have with the entity existing in Scotland and around that, So again, 20 or so roughly, $21 million, slightly more, has been spent for this facility. It's something unique, and I will show you a bit the capability of this facility just after. So for some of you, if you are much more on the metering side, an expert in this domain like me, the type of reference system that we will have on the gas will be Coriolis for the small flow rate, and we are using ultrasonic. USM is for ultrasonic, and you can see the size as presented in this table. For the oil and water, we will have a twin system, so it will be identical, 1 inch, 2 inch, 4 inch, and 6 inch Coriolis. These Coriolis, needs to be traceable. They need to be calibrated under pressure and temperature, and we have one of this facility here, so we'll be able to take any Coriolis. We are not here to tell you which one we have been using, but obviously they need to be corrected for pressure and temperature, and this is done on the specific facilities that we have, which is called EPAT. EPAT is for elevated pressure and temperature, which is used all the time, for all the equipment, either ultrasonic or Coriolis going on the North Sea side. So what are we talking, when I say that we will have large flow rate? You can see the number right now. I will mention the one in the field unit. I prefer this unit, So in oil, we will go from basically 0, but, the lowest flow rate that we can get in oil will be 30 barrels per day, and the bigger one will be slightly above 83,000 barrels per day, with an uncertainty, below 0.5%. For the water, it's exactly the same, and for the gas, we will be dealing with something close to 0 to more than 358 million of standard cubic feet per day. It's not a mistake. It's really the case. It's 358 million of standard cubic feet per day. So by far, it's something very, very, very high, and probably it's something that you don't see very often in your life when you're in a field. In terms of pressure, we will go from slightly above 200 psia to above 12,000 psia, if you prefer 140 bar or 141 bar. Temperature will be in a range of the 10 to 43 degrees C here, and I didn't mention it earlier, but the height of this building, or at least the equipment, could be up to 10 meters tall in this case. I mentioned briefly the area, for the test, which is 40 by 7 meters. And obviously, we can go from single phase, oil, water, or gas, to multi-phase, and we can go with any concentration of the 3 phases together. What type of fluid we'll be using? I said earlier, we will go with non-miscible fluid. So we are using, in this case here, some refined oil, which will have a viscosity quite low, if I can say that, in a range of 5 centipoise. We will use some salty water. This is what we have most of the time in a field. We can obviously, use fresh water if it's necessary. And for the gas, we are going to use nitrogen, which will be extremely dry, as you can see the number there. In terms of size of equipment that we'll be able to use on this facility, it will go from 2-inch to higher than 14-inch. We have few things around, and one of them which could be interesting, it's we have some choke, including some subsea choke. If you want to test a subsea meter, for example, either upstream or downstream a choke, we have such equipment here, and obviously we can provide it. The facility will be like the other one, ISO 17025. It will not happen, obviously, at the beginning, because you need to go through the process of the validation, but we are starting some of the work right now, including, as I mentioned about the traceability. So all the equipment that will be used there are already used and calibrated multiple times on the other facilities to be sure that we are totally in line with the expectation of the ISO. So if we look at now something quite interesting for the people in the multi-phase business, we look at what we say the working envelope of the facilities, and on the x-axis I'm presenting the gas flow rate. Here I'm presenting it in actual cubic meters per hour. So actual cubic meters per hour means at line condition, and on the y-axis I'm presenting the liquid flow rate, so it means the oil and the water also actual condition. I give some color, orange, green, and a bit gray, and these are presenting, the area of wet gas. There's different type of wet gas, a type 1, type 2, a type 3, but you can see what we can address, and I will see it in a different manner just after. There is some dashed line in the middle, and all these lines are representing the maximum working envelope, for multi-phase flow meters. The black one is, for example, about 8-inch meter. The red one is about 10-inch. The gray one is about 12-inch. So the message I want to pass here is even if you build or if you are buying a 12-inch meter, there is today a facility in the world, which is capable to address the entire range of this equipment, a full blast, and telling you if it's working or not. And this is very important because that if it's a large flow rate, it means there is a large amount of money in one way or another going through, either gas or oil, and you want to be sure that it's working very well. And the uncertainty claimed by the manufacturer can be demonstrated on the facilities before you install it in a field. So, I'm presenting the same thing here, but talking about the type of fluid that we are addressing. So we can address the wet gas type, the gas condensate, the volatile oil, the black oil, and obviously the production on the manifold. So if we want to look at it now from the same graph than before, but this time I'm presenting the logarithmic scale on the X and Y axis, and I'm presenting the three facilities that we have here. In the red, you can see the multiphase facility that we have, which is low pressure, but we can have different type of fluid, including very viscous fluid up to 2,000 centipoise. We have in blue the wet gas facility, which is at higher pressure, around 63 bars, and obviously target much more what I presented in red and orange, gas condensate and wet gas. And what you see in green here, it's the AMF, which can address all the type of condition, and obviously going much higher in terms of flow rate than the two other facilities. If we try to look at a bit, because I was mentioning to you that it's one of the biggest worldwide, or it is the biggest worldwide. I'll show you here in this web diagram, what we are targeting. So we have the highest oil rate, water rate. We are not the highest, in terms of pressure, but all at 50%, 60%, and in gas, it's the same things. But if you start to look at the entire combination or investigation that we can do, we are by far the number one worldwide. So what can we provide here in Nail today? It's what I'm listing here. We can look at from brown field to green field, from heavy oil to wet gas, and as I said, very large flow rate, in terms of gas or liquid, including, some 4 phases on the different facilities, And this is what we want to address, and with the highest level of uncertainty. So I'm trying to show you here with this pyramid, where fit the manufacturer and third-party facilities in terms of uncertainty in such equipment, And what is very important is you start to be in a third-party calibration or facilities, when you are in the green side, and obviously the uncertainty start to be smaller, and there is essentially 2 types of third-party facilities, You have the one which are ISO 17025, so they follow some special procedure, which it's a higher standard than the one which doesn't follow it. And then you have above, on the top of that, you have all the National Measurement Institute, and that is one of the unique one around the world capable to address teeny uncertainty on the reference measurement, and therefore to evaluate properly the performance of multiphase or wet gas meter. So I've been told that I don't have so much time right now, but I want to tell you a bit more on the meaning, as I said earlier, of the advanced multiphase facilities, because it's only the tip of the iceberg, as you can see here. Nail has been investing on their own, a fair amount of money. Obviously, we could not cope with $21 million, but we went almost with $1 million, and the idea here was not only to have a larger facility with the latest techniques around, but it was to provide some equipment which are unique, and which has been designed with some specific manufacturers, to address or to understand the fluid mechanics associated with 3 phases. And I will go just briefly, we will go through, we developed 2D 3 phases X-ray devices, and the idea of this equipment was to be able to look at in real time how the flow behaves inside a pipe by using, as you may understand now, some X-ray. And X-ray, it's something that you, for sure, you have been using in one way or another in your life, or you have been the cobaye for that, when you have been going to your dentist or a chest X-ray, So we have this equipment available today, and we do a full tomography. It's a big word here, but we do a tomography of the pipe, and imagine that we have some cell which are 2 millimeters by 2 millimeters, and we are capable to tell you that inside this 2 millimeters square, we have either oil, either water, either gas, and we can rebuild all the flow. What can we do? I'm showing it here. The system has some detectors on the side and on the top, and we are capable to look at the fraction in real time of oil and water in average, but we are capable in 3D look at, for example, the interface gas-liquid, as you can see it here in pink. We are capable to calculate the fraction of gas and liquid that we have inside the pipe in real time, and we are also capable to make a differentiation between, in red, the oil, and in blue, the water. So this is in real time. So here you can see we can calculate, for example, the length of some slugs, and this is done in real time. There is some video associated with that, and you will find it on the website. We are also capable to calculate, in real time, and here, I mentioned between bracket 120 frames per second. The maximum speed that we can get is 191 frames per second, or 191 hertz if you want, and we are capable to look at either on a full pipe or on a specific place inside the pipe, the water-liquid ratio. Water-liquid ratio means how much water is inside the liquid, There is a video, but I will skip the video because we don't have so much time right now. And I will try to show you a bit what we do with such equipment that we have. Okay, so not only you have the measurement, but you can use this measurement, from the X-ray to be able to use the CFD and look at much more in details now with some calculation, how behaves the fluid inside your pipe. I'm showing you one case that we have done on the side, where you see, I'm just showing you here the velocity of the gas, when you have a blind T, the restriction is a venturi, and when you have an elbow just after the venturi. When it's red, it's where you have the highest speed, and when it's dark blue, it's where you have the lower speed. So we are capable to look at these things. We are capable to link this CFD with the measurement I was mentioning before with the 2D three phases X-ray or the opposite. You can see it for the oil here. We can identify some turbulent area or recirculation area where you may or you may not want to have some meters or sensor present, and you can look at it also with the water. I will look at a different type of situation. I was showing a venturi, but it could have been something else. The last one, that we are developing and validating right now. We have them, we are validating them, and it's associated with some local measurement. As you have seen it very briefly on the previous slide, there is some area where you may have more water or more oil or more gas, and it may be interesting, if you want to do a sampling or if you want to use a specific sensor, and we have been working with a company, and we have multiple type of local probes that we can use to identify the property of the fluid in this area. So I show you the set of probes on the right side, which are like a needle, they are slightly smaller than 1 millimeter in diameter, and we have some probe carrier on the side. We have two probe carrier on the side with 18 slots, and we can install this wherever you want, either upstream, downstream, or if you have a hole somewhere, we can plug it, and identify the type of fluid that is passing, and therefore have access to the flow structure of the flow. So, to summarize, where are we, with the advanced multiphase facilities? So, it's obviously a high pressure and high flow rate facility, which is built, and I was highlighting it for multiphase and wet gas, but obviously we can also do a calibration of single phase. For example, for gas, you can imagine you want to calibrate a 14-inch venturi or vortex or whatever, it can be done here. The AMF is also, and this is very important, is the second bullet I'm presenting, it's an enabler for the National Flow Measurement Institute. As I said, we are NMI, and we have few facilities here, therefore we are the institute capable to look at flow regimes, but also research in flow measurement. We can help, in a comprehension of the flow structure, validating some models, which are developed for some virtual metering or any type of software system. It's also a place, I hope you understand through this presentation, where we are really open to look at any technology and helping you with a facility or our expertise, to develop further your system. And obviously, by addressing the high flow rate, we expect that it will be a high return on investment for your equipment. Okay. The key part is in the bottom, and very often forgotten by people, coming to our facilities. We are absolutely impartial and independent laboratory, and we are certified ISO 17025 for all of them, except for the moment the MF, because it's finishing to be built. A summary of what I said. We are addressing all the market, but I can see clearly the subsea, the production and allocation market, where the uncertainty is very important, and the wet gas business. We are looking, for high pressure here. We can go down, to 15 bars, but we can go beyond 140 bars for any type of meters. We can go for small size, 2 inch to above 14 inch, and we can, obviously, with such facility, avoid or look at any dispute that could exist, between custody transfer or allocation, as you may know, and we're also capable to look at the performance of any type of equipment, including water cut meter, with variation of salinity. Okay, we are. If you don't know exactly what is an MI, you may know that it's a primary calibration facility. So this is the highest level of quality measurement that is possible in the world. There is not more than one in each country, and we are very proud to be this NMI for flow measurement and density. So before I finish my talk, I wanted to tell you that we have been also engaging oil and gas company and some universities since a few months on some GIP and GRP. I mentioned just below what is it. The GIP is a Joint Industrial Project, and the GRP, it's a Joint Research Project. We have 2 GIP ongoing right now. One where we are looking for the interest of the oil and gas industry, for the verification of the multiphase and wet gas meter. Now that there is a big facility, a new facility, and nobody has been capable to calibrate the meters on this facility, it could be a fantastic opportunity for the oil and gas producer, to look at the true performance of meters on the market. We have done also the same thing, GIP on the water cut measurement. We have seen a big interest over the last years on looking the accuracy or how to detect the water. You may know that we are producing roughly 3.5 barrels of water for 1 barrel of oil. Obviously, people want to know how much water they are producing, because this is having a negative impact on the financial side, And not the least, the Joint Research Project, where we want to look at and revisit now that there is a facility with some tools, as I presented earlier, where we can look at the flow mapping, the flow structures, the flow regime. This could be associated with people developing software or universities which are looking, for some facilities where they can collect data and then they can work on that. So we are totally open on that. It's something very important for us to pass knowledge or to have a facility available for them. So these 3 projects has been discussed in Aberdeen. You could contact me or Marietta, that she was speaking earlier and will speak just after me, about how to be part or join this project or to know a bit more about them. So I think I reached the end. Almost on time, I think. It's quite amazing for me. And I want to thank all of you for that. And I suppose, Marietta?
Yes, thank you for that, Bruno. I think we might have time just for one very quick question. If you just bear with us, we'll just see if we can pull up a question. As I mentioned earlier on, obviously we've kind of run out of time today, but Bruno will be able to get back to you after the event with the answers to your questions. They're all saved on the server. Do you want to take one quick question, Bruno, and then we'll wrap up the event?
Yeah, I will take 2 because they are quite simple, as I can see it. Some people are asking me, about the price to access to such facilities. We are working on a 12-hour shift here, and the price is depending on the pressure that you have. But let's say you are around 14K or slightly above that, versus the pressure. The other one, which I thank people, it's what are we planning to do with the previous facilities, the multiphase facility and the wet gas facilities. Well, in fact, we continue to use them. We have a very high demand, on the wet gas, so definitely the wet gas facility will stay as it is. And you may have understood from my presentation, even if I was a bit fast, the multiphase facility is a very, very versatile facility where we can change the fluid easily, and definitely looking heavy oil or some other fluid, crude oil, for example, that we cannot use at this stage inside the new facilities. First for price, we are talking about roughly 120 cubic meters of water and oil, in these facilities, and obviously we have decided to use some specific one because we need to calibrate equipment against this one, and changing fluid will mean different type of calibration to do. So at this stage, you can see the three facilities have a synergy between themselves, including the single phase that I mentioned earlier, which one of them, the elevated pressure and temperature, will be used to calibrate not the Reynolds, but the Coriolis for the main facilities. I think probably I will stop here.
Okay.